All right, we are coming to the end of our study of exponential functions. The start thinking part on this problem says Yanni's trying to figure out if the following graph is linear or exponential. Specifically, they're wanting to know if the graph is modeling the equation f of x equals 120 plus 3.7 to the or 3.7x, or g of x equals 120 times 1.03 to the x. Now, originally, if I had to pick between which one, because it says, what do you think? Explain your reasoning. What are some things you could check? I would originally think that this one was going to be f of x because it looks very much like a straight line. So I would probably say that that is just f of x. If you actually look into it though, g of x, even though it's exponential, is barely curved at first. And when we're looking at that, it almost, if you actually graph this over this certain window that they're showing here, it almost looks flat as well. So that's not good enough. The next thing I would have checked, I was talking with the students of easy things you can look at. The first one that I'd look at is hopefully one of them has a positive increase and the other one is actually decreasing. But that's not the case here because 3.7 is going to be going up as x increases, and 1.03 for that exponential is also telling you it's going up. So that's not good enough. Another super easy thing to check would be your original value at 0, your vertical intercept. The problem with this is both of them have one of 120, so that's not good enough. The next thing you could have checked was the furthest along on the graph appears to be at about 7, a little bit more than 7. I just went with 7. There are ticks after that, but if you check 7, there's a problem with that for this one because you end up getting 145.9 versus 147.58. That's not enough for us to be able to see the difference on this graph. So the correct answer for here was, we don't know. This could be one of them or the other one. We're not sure. It says, how could the graph be different so that you could have a definitive answer? Student said, just zoom out. If this was on like Desmos or something, if you just zoomed out, you would, when you start increasing your x values, you're going to be able to see if the thing continues in a straight line or if it is going to start curving. And if it's curving, it's exponential. And if it's not, then it's that linear one. So that would probably be the easiest way. The other thing on Desmos is you could grab the graph and just slide your point over to 7, and you will be able to see if it is 145 or 147, and that would be definitive as well. So what we're looking at here in this first problem is just the difference between linear and exponential when we're talking about the graph. Now, our second problem here is an application. It's talking about this person, Ariel, wants to invest money in a business. Company A is willing to give her $500 each year for her $10,000 investment, and Company B is willing to give her 4% dividend, which is just like what they give you, a percentage of what you have invested in per year. And the deal is you can reinvest that. So it's not that you stay at 10,000. You can get that 4% and put it back into the business, and now you have more money invested. The first question says, which one of them is exponential and which one is linear? So one of them has a constant rate of change of $500 per year, and that would be Company A. So that one's linear because it has a constant rate of change. And then the 4% per year is going to be exponential because it is a different dollar amount per year depending on the year, and it's going to have like a constant multiplier that you're going to always be multiplying or dividing by the same number. Now, what are the equations for this? You should remember that linear we usually model in y equals mx plus b form, where m is going to be your slope or your rate of change, and b is your y-intercept, or in this case, your original amount. I wrote it slightly different. I said y equals b plus mx. So you could see the original amount plus $500 per year. The next one is going to be exponential, and it's exponential growth. So we were able to do the y equals a times 1 plus r to the x, and you get 10,000 times 1.04 to the x. The next thing it says is that they wanted you to graph this on Desmos and alter your window so that you can see the important parts of the graph. So when students graph this, you couldn't see anything. And when you zoomed out, it just made no sense. The graph went from like negative 300 to 300, and nothing made sense. You don't want to be looking at negative years for this problem. And it doesn't make sense to go to like 300 years. So what we were able to do is change the window, and we said, hopefully we can see everything we need in the first 30 years. So we went x being 0 to 30. And we said, if they're starting at 10,000, maybe if we went to 40,000, that would be enough. So we went over and went from 0 to 30, and then we went from 0 to 40,000 on the y. And when you actually look at this graph, you cannot answer the question where it says, should she invest in company A or B? It kind of ended up being, it depends. Between 0 and 11.9 years, if you put this into Desmos, you will find out that it would be better to do with the $500 per year. 4% for those years is not enough. It just doesn't. It's not going to be more. The linear graph is actually higher, has a bigger output than the exponential. And then after 11.9 years, that's when the exponential actually catches up and starts being higher. So really, should she invest in company A or B? It kind of depends. If she's going to be going between 0 and 12 years, it's better to just go with the $500 per year. If she knows she's going to hold this for 30 years, then she should go with the 4%. Now, a wonky thing here is there's a standard that they have for this class which wants you to know that no matter how steep a linear is and how non-steep an exponential is, if you go out to infinity, if you look at the domain going out to infinity, the exponential will always catch up with and get higher than the linear. It has to. So exponential will always end up being higher than the linear at some point. Let's get back to this though. It says, what does the solution of 10,000 plus 500x equals 10,000 times 1.04 to the x mean for the problem? Well, the answer is x equals 11.9 if you were able to solve this. And that's just saying that the output, the amount of money you have at 11.9 years for each one of them would be exactly the same. Now, before we can get into the actual part of this lesson, I had to go over a different concept here. And so this is an introduction to proof. It says, what do you know about an even multiplied by an even? Students were able to quickly say, oh, it's an even. And I said, what do you mean it's an even? Well, they said, well, 4 times 2 is 8, and an even times an even is an even. See? The problem with that is that's only looking at one case, when the even number is 4 and when the other one is 2. That is exactly one case. Now, the issue in math is to show something does not work. You only have to show it doesn't work in one case. So, for example, if I said it snows every Tuesday, you could say it's not snowing today. That's enough. You only have to show it doesn't work in one case. If I say it's always sunny on Tuesday and you look outside and you say it's sunny, I say that's not enough. That's just one time. They say, well, last Tuesday was also sunny. That's not enough. You can't look at 2 or 3 or 5 cases. You actually have to look at infinitely many cases. Okay? So instead of looking at one case, which is what you need to do when you're proving something's false, you have to look at infinitely many cases. And the question is, how do we do that? And the answer is we use variables. So you cannot obviously list out every single even number, but if I say n can be an integer, then 2n has to be even. Evens are always written as 2 times some number. So an even number, 2n, times another even number, I'm going to call it 2m, because if I said 2n and 2n again, then that had to be the same number. So 2n times 2m, those are 2 even numbers, is going to equal 4nm. And if I can write that as 2 times something, then that must also be even. So we know that if something can be written as 2 times something, then it's even. So we had 2n times 2m equals 4nm, and that can be written as 2 times 2nm. And that, since it can be written as 2 times something, is even. And just to throw this out there, you can see in the top right corner, I say, well, if 2n is even, we know the next number after an even is always odd. So you could call it 2n plus 1 is an odd number. Now, the whole reason I showed this is just to show you that if you're wanting to look at infinitely many cases, you can use variables to be able to do that. So on this one right here, we're looking at rates of change. This is linear. If, and the equation is y equals 2x plus 5. If we're simply looking at what is the rate of change between the 2 consecutive values of 0 and 1, if you find out the slope between 0 and 1, you find out it has a slope of 2. Now, how about between 2 and 5? Well, if you look at that, it's a change of 6, rise, and a run of 3, which is still 2. So you'd be tempted to say that the rate of change is always going to be 2. Now, what we're going to do here is actually prove it. So rather than just saying that we know it's linear and linear is always going to have the same rate of change, we want to pick a number and the next number. And rather than saying like 7 and 6, which are just two exact numbers, that's not looking at infinitely many cases, or 5 and 4, or 199, just looking at any number in the one before, I'm going to go over, and you could either say the number is x and the number before it is x minus 1, Or the way I found two consecutive numbers was x, and the next number would be x plus 1. And what I did was I just found the rate of change. I did the rate of change, which is change of y over change of x, with x plus 1, minus the number before it, which is just x. So I took the equation y equals 2x plus 5, and I said, what is that value going to be at x plus 1? So I substituted in x plus 1, as you can see there. And then I subtracted away what the y value would be with just x. So I substituted in x. And that is the change of y all over the change of x. The change of x is x plus 1 minus the one right before it, which was x. And when you simplify this, you got to make sure to remember that you have to distribute that negative. When you simplify this, you end up getting the number 2. That is not between like the x value of 10 and 9 or 7 and 6. This is between any two numbers, x plus 1 and x. And you found out that between any two numbers, the slope has to be 2. So you're not looking at any specific values of x. You looked at the arbitrary just x and x plus 1, any number and the next number. Let's find out the slope between x and x plus 1. You could have done between x plus 2 and x plus 3, and that would have also worked out the same. Which is between two values, the easiest way to talk about it is that x and x plus 1. Now we're going to do the same thing in the next case, but we're going to do this with exponential, and we know the common ratio should always be the same. So if you look at the ratio from x being 3 and then 4, the two consecutive numbers, you end up getting 3. If you look between 8 and 7, you get 3 again. So we know that that rate, when we're looking at this, when you're looking at the growth factor, it should always be multiplied by 3 to get from one number to the next one. Okay. Now, once again, we don't want to pick specific numbers because that you're not allowed to do that in math. You can't look at just between 5 and 4 or 8 and 7 or 199. We're going to look between two just random x values, and we're going to call it an x value of x and the next number, which is x plus 1. Okay. You could have also done x minus 1 and then x. Those would be two consecutive numbers. And I just substituted in my values. So we are going to look at the ratio between when I substitute an x plus 1 in and when I substituted in an x. And you guys need to remember the rule that you subtract your exponents. So 3 to the x plus 1 over 3 to the x, when you simplify that, you just get 3. And you're able to actually say that between any number and the previous one, the ratio has to be 3 for this. So this is looking more at the proof aspect of math. Let's go ahead and look through your homework. The homework says, whenever the input of the function increases by 1, the output increases by 5. That's basically saying that the common difference is going to be 5. So it is going to be a constant rate of change. And the only two that have a constant rate of change are A and B because they are linear. And the one that is actually going to have a rate of change of 5 is going to be B. Okay. The next one says that you have this exponential function, f of x equals 2 to the x, which of the following is true. And it says, the first one, as x increases by 1, f of the output is going to increase by 2. That is not true. That would be a constant rate of change. The next one says, as x increases by 1, the factor is 2. That would be correct because we know that we're talking about common factor, like the common factor or the common ratio when we're talking about exponential. So that's true. The next one says, as x increases by 3, the output increases by 8. Once again, that is going to be linear. That is a constant rate of change. And then the next one says, when x increases by 3, the output increases by a factor of 8. And when you look at this, you can see if you multiply by 2 to get to the next number, then multiply by 2 again, and then multiply by 2 again, that is a factor of 8. Like multiplying by 2 3 times is 8. So that one is true. And then E is not correct. When you increase by 4, the other one increases by a factor of 4. That is not correct. It would actually be 2 times 2 times 2 times 2, a factor of 16. On this one right here, it says, given the following, given the linear function f of x equals 6x plus 4, what will f of x plus 1 minus f of x? It's saying between any two numbers, how much will it increase by? Since this is linear, we know it always increases by the same exact amount, which is your slope. And it doesn't matter if you're going from an x value of 1 to 2 or 100 to 101 or 1,000 to 1,001. We know that linear, it'll always increase by 6. So that's why I got 6. On the next one, given the following, what will the factor be between any number for x and the one right before? Looking at this, 30 is the original and 2 is the factor. So we know that between any two values, the ratio has to be 2. The next one is saying for this exponential, when will the rate of change be bigger? So that's what it's asking. When will it actually be increasing? The outputs be increasing. Does it increase more between any value and between x and x plus 1 or x plus 5 and x plus 4? Well, we know x plus 5 and x plus 4 is going to be further along, and we know for exponential growth, further along it gets steeper. So that would be the x plus 5 and the x plus 4 would actually give the bigger outputs. And then it says, when will the ratio be bigger? Is it between x and x plus 1 or between x plus 4 and x plus 5? And we know the ratio is always the same for exponentials. That's why it's equal. I know this can be confusing. The next one, for the linear function, which of the following is true? Explain using your understanding. Is it always going to be, is the difference between x and x plus 1 going to be the same between x plus 4 and x plus 5? Are the differences always the same, or are the ratios always the same for linear? And we know the differences are always going to be the same for linear. So since they said it was linear, and A is talking about the differences, not the ratios, it's got to be A. And then the last problem was a lot like the one we did in class. One of them, they're giving $600 per year for like a bonus, and the other one is going to be making a 2.5% raise on the previous year. So which one is linear? Which one is going to be exponential? Well, the one that is a constant rate of change of $600 is going to be linear. The 2.5 is going to be exponential. So we have that. What are the equations? I modeled them based on y equals mx plus b versus y equals 1 plus r to the x. Then when you use Desmos and you adjust your window, you find out between 0 and 15.2 years, it's better just to do the $600 per year. And after 15.2 years, it'd be better to be at the 2.5%. All right, hopefully that made sense. Thanks for watching.